So, you've seen already our next speaker because he was also one of our sponsors, and he will tell us a bit about a side project he had for quite a long time. Please welcome. No, you're not ready. Okay, so let's do a bit of claquette in the meantime. What else can I say? So it's a good friend of mine. We've been hanging out for a long time, and he's a very passionate iOS developer and also entrepreneur in the mindset. So please welcome Mac.
Hello everyone, again. So I'm still Michel-André Chirita, and now I will talk about a side project I've started 2 years ago. To give you some context, I have been a developer for more or less 20 years. But since 10 years, I've only worked on iOS applications. And I wanted to explore something different. I wanted to build a game, but not any game. I wanted to build a game for iPhone, iPad, with artificial intelligence, with real-time online multiplaying, without any backend, with one no, this one. We can stop there. So I asked myself, is it possible to make all of this only with Apple frameworks as a solo developer during my spare time? And the answer is yes. This is the result. I was able to do pretty much all the features I had in mind, but with some tough moments and some good surprises. Today, I'll share with you 5 learnings from this experience. First, we'll talk about things I thought would have been easy, but haven't been, at least in my experience. Also things that could have been more difficult, and some architecture, artificial intelligence, and online multiplaying. But first, my story needs a hero to help me illustrate it. So please welcome our hero, Del. And yeah, the other guy. Let's start with the first learning, easy things that are not so much. One thing you'll need to do when you make a game, same as for applications, is to adapt to different devices and so different screen sizes. Even if SK View is a subclass of UI View, there is no auto layout in SpriteKit, and no other magic tool to handle different screen sizes. You'll have to handle it by yourself, depending on how you want your UI to scale. Then maybe you'll want to have a drag and drop feature, which is pretty common pattern in games. Same, there is no built-in method to handle drag and drop. You have to implement it by yourself using the UIKit touches delegate. Yeah. I would recommend to make a state machine with the 4 possible states and use the JK state machine implementation built-in GameplayKit. Next, we'll talk about a bouncing ball. There is a physics engine in SpriteKit, which simulates real-world movement, collision, gravity, friction, etc. It's pretty cool, but I had some difficult time figuring out why the exact same code produced 2 different results on 2 different devices. What's the difference? The answer is that scaling the scene size to adapt to a bigger screen affects the mass, which in my example changes the ball behavior. Yeah. So with all objects the exact same position, size, scale, and physics parameters, SpriteKit physics can be deterministic, and you'll have the same results each time you run your code on any device. In conclusion, you probably won't find every feature you are looking for included in SpriteKit. Deal with screen sizes from the beginning, check on every screen format, adapt to your needs, and think about accessibility, make Robin happy, the minimum touch and read size. If you need drag and drop, use a state machine, check all the touches, and use a physics body if you need a contact detection for the drop position. At last, the physics engine has deterministic results if you carefully control all the parameters. Learning 2. There are also a lot of nice building blocks making things a lot easier than I thought. When you are used to UIKit animations, this is something you should like. Here we are chaining some UI actions like moving, scaling, rotating, and it's so easy and nice. The physics engine is also pretty powerful and cool. Here we are simulating one object that follows the other one anywhere it goes. It's also so easy and very fun, and yeah, you should try it. Matchmaking with GameKit is also a very good example of a difficult-to-build feature, very easy to implement. You can reuse the given UI or build one custom-made by yourself in a few lines of code. There are many more nice building blocks I can't go into detail today, like entities and components for role composition, agents, goals, behaviors, for autonomous movement, for example, for enemies moving automatically, controlled random values with setting a source and a distribution, or graph path obstacles for pathfinding, and many more. To conclude, there are a lot of nice building blocks in these frameworks, and most of them are very easy to implement. I will strongly recommend to explore the documentation to avoid reinventing the wheel by yourself. Learning 3, architecture. The most basic way to architecture a game is to tie everything together. But as you can imagine, it's not a good idea. First, we'll split the display and the logic parts. Then, we'll define what are the scene events and that are sent to the logic layer, basically the user actions, and what are the actions that will be displayed in response. Let's have a look at the implementation. So first, we need a state describing at any moment where the game values are, like the game time, the score, the character position, or other key information. We'll use a struct for that. Then we'll make an enum for all user inputs, like when the hero or its opponent is moved. And we'll add all additional information that is needed to evaluate the change, here the new position. For each new event received by the logic layer, we need to evaluate how it impacts the state and what is the result to display. For example, when the hero moves, the state has to be updated to reflect the new position. The change of position triggers a display action that is sent to the UI layer. Same for all the events. And finally, we'll check if the new state reflects a victory for one of the players. In that case, we send a dedicated display action. Next, we'll do the same thing for the UI part. Now we have an enum for all the actions that can be displayed. It contains all the things that our UI can handle. Here we are updating the UI by animating the nodes with the SK action moved to a CG point. Same here. And finally, it will present the game over menu when there is a winner, of course. To conclude this part, I will strongly advise to separate the game logic and the display layers, use a global state and enums for defining all interactions. This will make your code more readable and testable, and it will greatly facilitate integration with features like artificial intelligence or online multiplayer. Learning 4. Let's talk about the artificial intelligence. Basically, AI will need to make a decision tree like this one, in which you can see an initial state 1 and all the possible actions that may happen from there. For each action, there are resulting new states, 2, 3, 4, that can represent a victory or defeat. The goal of the AI is to find the shortest path to victory, like this one in my example. GameplayKit offers two strategies that will handle this slightly differently: min-max and Monte Carlo. Min-max will try to explore every possibility. There is one parameter setting a depth limit. It will return any victory path found in this range. Monte Carlo will seek a compromise between exploiting choices that look promising and exploring nodes. It applies the concept of large numbers to randomly filter some of the possibilities. And it also has some parameters to define limits. To synthesize, min-max will have better results, but is generally slower. Monte Carlo should be faster, but also has less good results. For the implementation, we'll bring back our previous architecture, and we'll add a new AI layer, which will ask for the current state and send back in return the selected update, hopefully leading to victory. Let's have a look at what information AI will need from our state. First, the state will need to conform to JK game model. This will ask to implement variables telling the strategist who are the players and which one is the next to play. Then it needs a score for the player and if there is a winner. Then, as we've seen before, you'll have to provide all the possible actions for this current state. Then describe how to duplicate the state. And finally, apply the update the strategist wants to evaluate next. Once we have the state, all we need to do is to ask the strategist what is the next best move for the active player. Yeah. To conclude that part, it's super easy to integrate an AI with the right architecture. The performances depends, of course, on the complexity, but it may be fast enough for real-time gaming. You'll have to choose wisely when and how to run it. Use JK min-max strategist when the decision tree is not too big, else use Monte Carlo. Learning 5. Let's talk about building the real-time online multiplayer feature. GameKit supports multiple ways to do it. The probably first solution we'll think to is to have a host server. All the clients will connect to it to send their inputs and get back updates. In this case, each client acts as a dumb display terminal. The inconvenience, of course, is that you need a custom backend, which may be quite expensive to build and require some specific skills. You can also choose a peer-to-peer solution where every client connects to all the others, or the ring peer-to-peer where each client connects to the next. It may be cheaper, but it's also a less robust, less scalable, and less secure solution. And the obvious problem is how to handle conflicts, as there is no one source of truth. The player-hosted client-server model solves this by designating one of the clients as being also the host. To improve it, we can opt for a hybrid player-hosted client-server solution, where each client has its own embedded logic service, local server, for very fast processing without waiting for the host. But only one remains authoritative in case of conflicts or when one single source of truth is needed. For example, for generating a common random number shared by all the clients. Now let's have a look at the architecture. We can now very easily include a multiplayer service between display and the logic, which will send and receive events to and from the other players. The implementation of Exchange Online Information is very easy. We just need to send an event to our multiplayer service, then encode it and call the send function on the JK match object, which has been provided by GameplayKit during the matchmaking phase. To receive events, there is a did receive data from remote player function in the JK-Match delegate. It's where you can decode the received data and use it to update the local state and display. Of course, you'll have to limit the payload size. This is why we only send updates and not the entire new states. Doing so, the connection is fast enough for real-time game. We have a good network connection, of course. But you'll need to handle edge cases, like connection errors and conflicts. And then you can add some magic. If each client is only displaying the remote events it receives, and if you want a smooth animation, you'll need to exchange a lot of data. This can be solved by adding some interpolation between positions. You can do this, for example, by animating very slightly objects between two received positions. If you want to go further, you can do as major games like Call of Duty by implementing predictions. There are many ways you could do this, depending on your gameplay and needs. But one simple example consists at guessing the movement of the object locally and immediately in response to the last received input. You can do this by calculating a vector between the last known positions. And this only works if most of the times the prediction is not too far from reality. And that correcting with the remote or host server values don't have too visible impact on the game experience. To wrap up this part, multiplayer connectivity can be easy to implement. Real-time is possible, but with limitations. And I will recommend to first concentrate on robustness, then optimize and add smoothness. Edge cases and optimizations are most likely to be the biggest difficulty and the most time-consuming. We are getting close to the end of my story, so to conclude, solo game development only with Apple frameworks is possible. SpriteKit, GameplayKit, and GameKit offers a lot of building blocks, but not everything I would have hoped for. With the right architecture, AI and online features are very accessible. And there are nice problems to solve. Most of them are about going from working to great, adding what is nice with game we likes. And last, it's fun. I hope you will try it and have fun with game development. Thanks for listening, and thanks to the organizer for inviting me. And last thing, if you want to try my game, you can use this QR code. It's available in the App Store, and it's free. So, yeah, do it. Thank you.
Thank you, Mike.
Yeah.
Thank you.
So I've been following this project like for years. We talked about.
You have been the first tester.
Ah, okay, okay. we talked about it like dozens of times, and I've always been impressed by the fact that you kept on working on it. So how did you find the will to keep on working on such a large project?
So first, I think my family and my friends helped me a lot. They support me they encourage me to continue and work on this project. I think you have to be curious. You have to like it. If you don't like it, you won't work at Friday night or something, or each weekend, or of course. And maybe you can tell a friend you will, do a speak at a conference. So you don't have a choice. You have to finish it.
Okay. That's why conference exists. When making predictions for online multiplayer, does iOS provide you with building blocks, or you basically had to do that?
Yeah, you have a lot of ways to do predictions, and there is no built-in a block to help you. But there are simple ways, like a vector. It's very easy, just 2 points or 3 points. Yeah. No, you don't have another building block to help you for that.
Okay. How much time in total, if you can, like,
it's a little bit difficult to say because it was at first 6 months of more than full time. Then 1 year and a half during my weekends and my holidays and some evenings. I think it's somewhere, maybe 1 year of equivalent full time. Yeah.
What's the state of the project now?
So it's live. It's available on the App Store. It's only a first version. I think I will continue. I will keep iterating and adding some features and something. But it's available, so you can try it and leave a review, 5-star, hopefully. Yeah.
So you learned lots of frameworks and techniques. Which of them are applicable to like normal app development?
Yeah, it's a good question. I think all of these are very easy to use inside any application because it's an Apple framework, so you just have to import the framework and it works. I can think to maybe SK particle emitter, which is the same thing as the UI counterpart, but it has more options. So maybe you can use it. Maybe you can do animations with nodes. As we have seen, it's very easy, much more easier than with. So if you want to have a gamification or something in your game, in your application, maybe it's possible. In fact, you can do it. After, you have to ask yourself if it's the best way or if you can do it another way.
If you had to do this project once more, restart it, what would you do differently?
I think I will try Unreal Engine. I'm not sure.
Unity?
Unity or something. No, it's, I will do the same, because it was very interesting. I learned a lot of things. So no, I wouldn't change anything, I think.
I have a question which actually regards the fact that you have been working on this project for kind of a long time, but I guess you took some pauses. How do you kind of documented the project so that like yourself or the future will be able or were able to understand what you did in the past?
Well, yeah, good question. So I don't have like unit testing or documentation. Yeah, I don't have anything, in fact. Maybe some comments in some tricky parts, but no, I don't have any documentation. Thank you for the question.
I think we said no talks about no testing, no documentation, so we was
too late.
Too late.
Do you do some PRs to yourself? Like, do you review your own code?
Yeah, exactly. And it's difficult, very difficult for me.
I'm sure. Great. Thank you, Mac.
Yeah, thank you.
Thank you.